All right, we're going to talk about simplifying cubed roots. We just did simplifying square roots, and simplifying cubed roots is very similar. So just a quick review. If we had to simplify a square root, let's say we had the square root of 27, what we wanted to do was we wanted to factor out or pull out perfect squares. So I would look at 27 and I go, oh, well, I can pull out a perfect square of 9. And then my leftover for that would be the square root of 3. So the square root of 9 is 3, and then my leftover would be the square root of 3. We're going to be doing the same thing with cube roots, only instead of trying to factor out perfect squares, we're going to be factoring out perfect cubes. So the first thing that we're going to do is we want to know our perfect cubes. Let's see. So let's go ahead and fill in. These are the things that you're going to be looking for that you're going to try to factor or pull out. 2 to the third is 2 times 2 times 2, which is 8. 8 is a very common perfect cube. 3 to the third is 3 times 3 times 3, which is 3 times 3 is 9 times 3 is 27. 4 to the third, 4 times 4 is 16, times 4 is 64. 5 to the third, 5 times 5 is 25, times 5 is 125. These are kind of the most common ones, and then these other ones, 6 to the third, I might get my calculator out for that one. 6 times 6 is 36, times 6 is 216. Obviously, you can go further than that, but these are going to be the main ones that should leap out at you. Let's take a look if you have a variable. Let's see, the cubed root of a perfect cube is just that number itself. So if I have x to the third and then I take the cube root of that, my answer is just x. Same thing if I have x to the sixth, this becomes x to the third times x to the third, because when we are multiplying, we add our exponents, and I'm taking the cubed root of that. Well, the cubed root of x to the third is x, the cubed root of x to the third is x, so this is x squared. Another way you can think about it is your exponent here divided by your root. So 6 divided by 3 leaves you 2. So let's talk about some examples. Example 1, simplify the cubed root of 873. The first thing you should think about is, okay, just identify that this is the cubed root and let that click in your brain. The biggest mistake that people make is they ignore that 3 and they switch it to a square root, which is a very different problem. So step number 1, factor out any perfect cubes that you can. So here's where you want to take a look at your list and go, okay, so the cubed root of 875, I go, is any of these a factor of 875? Aha, 125. I'm going to factor that out. So the cubed root of 875 becomes the cubed root of 125. And what's left over? 875 divided by 125 is 7. So the cubed root of 7. That's my leftover, I call it. So step 2, now I'm going to simplify the perfect cube. So the cubed root of 125 is 5. Okay, so that's 5. And then my leftover just stays a leftover. So I could write it as 5 times the cubed root of 7. Or I could just cross out, I don't have to include that little dot there, and I could just write 5 cubed root of 7. Those mean the same thing. Just a caution, make sure that you do include that cube root right there, because if you write this, 5, that is saying 5 times the square root of 7, which is a very different problem. Let's do example 2, which includes some variables in it. Again, we're going to do the exact same thing. Step 1, factor out perfect cubes. Well, let's see. My -2 just stays the same. I'm not going to bother with that. I'm going to take a look at this 135 and I go, ooh, what will go into 135? Ooh, and here's where you can just take your calculator out if you don't really know and just start going. Well, let's see, 135. I know 8's not going to go into it because it's odd. Let me try 27. Oh, it goes in, yay. 5 times, okay. So I'm going to factor out a cubed root of 27, and then over here I'm going to kind of have my leftovers of 5. So there's 27 and 5. Now I'm going to attack these variables. Let's see, I want to take out perfect cubes. So I know that x to the third is a perfect cube. I can take out another x to the third. That's another perfect cube. So far I have x to the sixth over here. And then I can't really take out another perfect cube, another set of 3. So here becomes my leftovers. I took out 6 x's, and I'm left over with 2, x times x. So here's my perfect cube part, and then here's my leftover part. Step 2, I'm going to simplify my perfect cube part. Okay, so this -2 remains the same, so be careful to not forget about that part. The cubed root of 27 is 3. The cubed root of x to the third is x. The cubed root of x to the third is x. And then here's my leftover part that can't be simplified at all. And then step 3, if you need to, just simplify all of these integers and variables and things like that that you have. -2 times 3 is -6. X times x is x squared. And then my leftover part is still the leftover part. So the steps are very basic. Factor out your perfect cubes right here. So you're going to have your perfect cube part and your leftover part. Simplify what you can, and then simplify again. Example 3 is doing the same thing, but it's doing a slightly different method, and you might like this method, so I wanted to go over it. We're going to use the prime factorization method. And just kind of a quick review on what is prime factorization. Let's see. Let's do a quick review. If I wanted to find the prime factors, well, I'll use this number here. 432. I want to find the prime factorization of it. I want to break this down into its prime factors. Lots of different ways I could do this. I'm going to divide 432. Let's see, 4 plus 3 is 7, plus 2 is 9. I know this can be divisible by 9. So 432 divided by 9 is 48. So 9 times 48. I'm going to break 9 into 3 and 3. And I'm going to circle them once I have my prime numbers. 48 I could break up into 6 and 8. Could break that into 2 and 3. Oops, sorry, I'll go up a bit. And then 8 I could break up into 2 and 4. And I could break that into 2 and 2. So now I finally have the prime factors, and now I'm just going to list them out. So I have 2, I have 1, 2, 3, 4, 2 to the 4th, times, and then I have a bunch of 3s. 1, 2, 3, 3 to the 3rd. So 2 to the 4th times 3 to the 3rd is the prime factorization of 432. That's just a quick review of prime factorization. Let's go back to our problem. We want to simplify the cubed root of -432, x to the 7th, y to the 5th. Yikes, that looks a little nasty. Let's go ahead and use this method. Step number 1, I would probably, with cubed roots, we can have a negative under our exponent. With square roots, we couldn't. Because you can never have a number times itself that's going to equal a negative. But with a cubed root, remember, we're doing a number times itself 3 times. You have an odd number, you can have a negative there. So I'm going to just factor out the negative, because I think that's going to be easier to use. So I'm basically factoring out a -1 to the 3rd, because -1 to the 3rd is -1 times -1 times -1, which is a -1. So here's my negative right here. Everything else has stayed the same. Now I'm going to go ahead, not forget about my negative, but I'm going to use prime factorization to completely factor each element. So I'm going to, my number and each variable. So 432, we just did this. That factors out to 2 to the 4th times 3 to the 3rd. X to the 7th, well, when in doubt, write it out the long way, right? That becomes x times x times x times x, okay, 7 of them. And y to the 5th is 5 of them. So that's kind of what I'm thinking about. So everything has been completely factored. Now step 3, now what I want to do is I want to pull out my perfect cubes, or if I want to think about it, my set of 3, because a perfect cube is a number times itself 3 times. And I'm going to group the perfect cubes together, and then I'm going to have the leftovers kind of over in their leftover group. So I'm going to go up here. So I have a perfect cube right here, because 2 times 2 times 2. And then I have a leftover 2. And then I'm going to group this one I have a perfect cube right there, 3 times 3 times 3. So that's where I get this group right here, 2 to the third. And then I have this 3 to the third. And my leftover 2 is over here on the leftover because it didn't have anything to match with. Then I'm going to go to my x's, and I have a group of 3 here and a group of 3 here. And then I have a leftover x. So 1 group of 3, 2 groups of 3, that's x to the 6th, because I have 6 x's, and I have a leftover x. Now I'm going to group up my y's. I have 1 group right here of a perfect cube, so that's y to the third, and then I have these leftover y's. Not quite a complete group of 3, so there's the leftovers. So I pulled out all the perfect cubes, which are all here, and then I have the leftovers. And step 4, just simplify your perfect cubes. So the cubed root of 2 to the third is 2. The cubed root of 3 to the third is 3. The cubed root of x to the 6th, 6 divided by 3 is 2, because I got 2 groups right here. And the cubed root of y to the third is just y. And then my leftovers just stays as leftovers. And then I'm just going to keep simplifying. My 2 times 3 becomes 6. And, ooh, you know what I forgot about? I forgot about this negative here at the top, so I need to make sure I add that negative back in there. Oh, those negatives, they are tricky. So my final answer is negative 6x squared y times, an invisible multiplication sign here, the cubed root of 2xy squared. One way to think about it, to kind of double check yourself to see if you factored all of your perfect cubes out, take a look at your leftovers. Your exponent should be less than 3. So like this exponent of x, there's an invisible 1 there. 1 is less than 3. And the exponent of my y's is 2. 2 is less than 3. If I have a 3 here, then that means I would have like 3 y's multiplied by together. I could take that group of 3 out. That would be a perfect cube. So your exponents should always be less than 3 in this case, because we're dealing with cubic roots or cubed roots. So there we go. So that is a method using prime factorization. Let's go ahead and do an example from our practice. All right, number 1, the cubed root of negative 500. I'm immediately thinking, okay, what are perfect cubes that go into 500? I think 125 might go into that, so let me check it out. I know 125 is a perfect cube. 500 divided by 125. Oh, yeah, it goes in 4 times. So let's see, that's going to be, the cubed root of, and I'll just do a negative 125 here. And my leftover is the cubed root of 4. And what number times itself 3 times gets me negative 125? Well, that would be negative 5, right? Because negative 5 times negative 5 times negative 5 is negative 125 times the cubed root of 4. And that is the answer. A lot of people kind of go, oh, 4 is a perfect square. Yes, it is, but we're not talking about perfect squares. We're talking about perfect cubes. Totally different animal. So don't get those confused. All right, have fun doing your cubed root practice.